Hi kids. Okay, this is not for everyone in the first place. I have seen couple of people who are scoring pretty less in physics and struggling what to study. So I'm going to show like what are the very basic important things which will help you score like couple of marks. Yes, I'm talking especially about the people who are barely scoring 10 marks, 20 marks. I mean, we can solve half of the questions using this anyway. So you can look into that. So in SHM, I'll be going with SHM now. So in SHM, you need to understand whenever there is equation like this, a equals to minus omega square x or x double dash equals to minus omega square x, that form is SHM form. Then the general solution is going to be x equals to a sin omega t plus phi, or you can write the same thing as p sin omega t plus q cos omega t. So most of the questions you need to convert it into this form, and if this is the form, this is the general solution, and if this is the general solution, time period is 2 pi by omega. Sinusoidal time period is 2 pi by omega. So that's the very important thing in SHM. Now, apart from that, a sin omega t plus phi, you can visualize a sin omega t plus phi like some guy who is performing uniform circular motion and his projection along x-axis or y-axis. Now, if some guy who is starting from here with constant angular velocity omega, after some time he will be rotating an angle omega t, then his horizontal component is going to become a sin omega t plus phi, his vertical component is going to become a cos omega t plus phi. So basically, this is nothing but SHM form. If x equals to this thing, then it is SHM. If you want, you can cross check, right? See, if x is this much, differentiate it, double differentiate it and check whether it is of this form or not. Differentiate it, double differentiate it and check it whether it will fit in this form or not. If this is the differential equation, this will be the general solution. You can visualize it as some guy performing uniform circular motion and his projection along x-axis or y-axis. Now, generally when there is a spring and mass, so this is the ideal case. From here you can understand a lot of things. When you pull it by distance a and when you leave it, it will keep performing SHM. It will be oscillating, we call it as SHM. That is a equals to minus omega square x. So when it is at some particular instant which is where the distance is x from the equilibrium position, then kx, I can write as net force is kx is equals to m into a, so a equals to k by m into x. If I write in vector form, displacement is in this direction, acceleration is this in direction, so a bar equals to minus k by m into x bar. So this is of SHM form. So time period will be 2 pi by omega, omega is root k by m, so time period is this much. Some people will be writing it the other way. When you pull it by distance and when you leave it, it is going to go back to exactly same distance. You can convince yourself by using energy conservation, and net force is going to be 0 here. Still it is going to go this direction because already velocity will be in this direction. Anyway, so when it is at a distance x and when its velocity is v and the acceleration is a, see, I assumed all are in the same direction so that I don't have to bother about negative sign. So basically v is dx by dt and a is dv by dt for me. I can write energy conservation when it is at some particular position, potential energy plus kinetic energy must be equals to total energy. At the extreme position, total energy is potential energy half k a square, kinetic energy will be 0. So total energy is constant. When I differentiate it, I will be getting some equation which is again SHM form. So time period is this much. So either you can write a force equation or you can write energy equation and you can differentiate energy equation. And when there are two things performing SHM along x-axis, then the resultant displacement will be given by summation of individual displacements. You can get it like vector addition form because we have already seen it's like phasors, right? Reference circle, whatever it is. So when thing is performing SHM, when two forces are of nature like k proportional to k into x form, when two forces are acting, then the resultant displacement will be given by summation of individual displacements. Without knowing this also you can do it. So basically in this chapter, if you want to solve half of the questions, you should be knowing this thing, and time period is 2 pi by omega, and reference circle horizontal component or vertical component is going to be SHM, and writing force equation and writing energy equation. By this you can solve 50% of the questions, if not more than 50%, right? Thank you.